Today we're going to learn something new. It's called types of chemical reactions, okay? And within that, we're going to go over how do you know a chemical reaction is happening, and what are the different types of reactions, and how can you tell the difference between them, okay? So I wanted to show you first where you can access this information at, all right? You're going to have to excuse my dogs in the background. So if you are on Canvas and you're on the home page, okay, you can access this PowerPoint that I'm going to go over. If you go to Tuesday, 6.3 notes, types of reactions. Okay, so that's where I'm going to be. I'm just going to do it out of Google Slides. Okay, so here's the thing, is whenever it's time for you to come see me again, you are going to be required to know this information. So I need you understanding, doing the best that you can, watching this video, reading over the PowerPoint, emailing me questions, all of that fun stuff so that you learn this material, okay? So let's go ahead. I'm going to talk through this PowerPoint. It shouldn't take me long. That way I can emphasize a few things and stuff like that. So let's go ahead and get to work on this. All right, so types of chemical reactions. This is our 6.3 notes for IPC. Our objectives, we're going to be able to determine when a chemical reaction is taking place, and we're going to be able to distinguish between 5 different types of chemical reactions. So let's knock out that first objective first. If you can see, smell, or hear one of the following or more, a chemical reaction is happening. So if you notice that it changes colors, if you notice that a precipitate forms, and all that means is that maybe you combine 2 liquids and a solid formed at the bottom, that would be a sign of a chemical reaction occurring. Along with any time bubbles are formed, if heat is produced, so you notice a temperature change, and if light or sound is produced, okay? If any of those happen, a chemical reaction has taken place, okay? Now, there are 2 types of temperature changes that we need to discuss. That first one is going to be something called endothermic, okay? And I always think of the prefix endo, meaning inside, things like that, all right? So what that tells us is that an endothermic reaction absorbs energy from the surroundings. It's going to take in any energy that's around. An example of this is photosynthesis, melting ice. Okay, an ice cube is going to take in the energy from its surroundings and melt. Cooking and evaporation. Okay, so whenever you cook a pancake, that batter is absorbing that heat from the skillet and cooking that pancake. Okay, the biggest thing that you need to know with endothermic is that it is absorbing energy. Exothermic is going to be the opposite of that. It's going to release energy. All right, and a few examples of those are condensation, rusting, fission. We talked about nuclear reactions, fission, how that's the splitting apart and it produces a whole bunch of energy. Okay, it spits out that energy, it doesn't absorb it. So that would be exothermic. Combustion, which is fire, and anytime you're burning something would be exothermic because you can feel the heat and you can see the light and stuff whenever you're burning something. Okay, the biggest takeaways here is that endothermic reactions that absorb energy get colder, and exothermic reactions get hotter. Okay, remember those 2 differences between endothermic and exothermic. All right, now this is going to be the more difficult part. I'm not going to lie to you, the types of chemical reactions. But if you can see them and take away all the numbers that kind of confuse you, it gets really easy. So we have 5 different types: synthesis, decomposition, single replacement, double replacement, and then combustion is our last one. So, synthesis, just plain and simple, you have a white circle plus a black circle, and at the end of the reaction, they're going to come together to form a compound. All right, so 2 simple circles come together to form 1 compound. All right, our definition of synthesis, a reaction in which 2 or more simpler substances combine and form a more complex substance. All right, an easier way to see this, aside from the circles, would be its general formula, which is A plus B yields AB together, okay? This is a real chemical formula. Carbon plus O2 yields carbon dioxide. So 1 thing by themselves, 2 things by themselves combine and form 1 thing together. Also, our formula for water. So hydrogen plus oxygen yields water. So 2 things on my reactants, 1 thing on my product. That's a for sure giveaway of synthesis. Okay, if that doesn't get it across, we can also think of it as a real world example, all right? And we're going to go with the story that Betty and Alan have started dating. Here's Alan, here's Betty, now they're dating. They were single beforehand, now they're together. So synthesis is the joining of two single things. Okay? Decomposition is going to be the opposite of that. So we have this compound with white, black, and gray. Decomposition happens and it splits up. That gray got separated from that compound, so it decomposed from the white and black circles. Okay? The definition of decomposition: a reaction in which a more complex substances breaks down into more simpler parts. So there's going to be a lot of breaking down in decomposition. The general formula, we have A, B together, and now they're separated. Okay? They decompose, they split up. Our chemical formula for this, we have sulfur oxide, splits up into sulfur and then oxygen just by itself. All right? And what is your prediction on our real-world example? Yes, hopefully you said that Alan and Betty have broken up. So they were dating, now they broke up, and they're single again. Okay, so that is decomposition, the opposite of synthesis. Now, single replacement can get a little tricky, but I've drawn these diagrams to kind of help you out. So going back to our circles, this is single replacement, so think of 1 for single. We have white and black together with gray by itself. This gray is going to boot out the black and take its spot. So now black is by itself and gray is with white. It just replaced gray. It just replaced that black one next to that white dot. Okay, so that's single replacement. Our definition of a single replacement: a reaction in which a single uncombined element replaces another element in a compound. So like our gray circle replacing our black circle next to white. All right. General formula: AB plus C is going to give us AC plus B. We'll see what that looks like in just a second. C went and replaced B, so now it's standing beside A, and B is by itself. Our chemical formulas, which you're going to need to know, would look like this. So I have zinc and HCl, and then on the other side, H is by itself. So what happened is zinc went and booted out H, and then it combined with chlorine in its place. All right? So an easy way to tell if it's a single replacement is you have one single one and a double. And on the other end, you have a single and a double. Okay? That's the best way to identify a single replacement. Okay? So in our real world example, things got a little bit hairy between Alan and Betty. Betty and Alan broke up because Kathy stole Alan's attention. Alan left Betty for Kathy. So we knew that Alan and Betty were dating, okay? And the reason they broke up is because this girl, Kathy, came and took Betty's spot next to Alan. So now Betty is all alone. Kathy and Alan are dating, okay? So single replacement is a little bit rough in the relationship world, okay? So if single replacement is rough, double replacement is double rough, okay? So we've added a fourth circle here, okay? We have a double, and we're going to end up with two doubles on the right side as well. What happens here is this: our white and our gray are going to switch spots. So white is with black at the beginning, but white is with blue at the end. Gray is with blue at the beginning, but now gray is with black at the end. So it's a double switch right there. Our definition: a reaction in which a positively charged cations, which are metals, of two compounds switch places to form two new compounds. So our general formula: we start with A and B together and D and C together. We end up D and A switch places. So now D is with B, A is with C. If I look at our chemistry examples, oh, those are not correct. I did not change those. Okay, I got to go back and fix those really quick. Don't look at those. That is a very bad example. Those are not good. Okay, we're gonna fix those in just 1 second. But let's get to our real world example. Okay, Kathy was originally with Doug. Since Alan took Kathy, Doug started dating Betty. Okay, so now Alan and Betty started dating. Okay, we didn't know that Kathy was with Doug, but then Kathy, remember, she booted out Betty and got with Alan. So now Alan's with Kathy and Doug is with Betty. So it's basically the boys switched girls. You know what I mean? Or vice versa. Okay, a double switch happened there. They just replaced each other in their relationships. All right, our last example is a combustion example. Okay, notice I only have circles on this first part. The rest are actual substances. These three things are never going to change in a combustion reaction. It's what makes them combustion. Okay, so if I look at my definition, a reaction in which oxygen reacts with a compound to produce carbon dioxide and water. So you know it's a combustion reaction whenever you have carbon dioxide and water produced, and then oxygen reacted with something in our reactants. Okay, so it's always oxygen, and then on the right side, it's always carbon dioxide and water. That part will never change. So here's our example formula. We have some random compound. Usually it is a hydrocarbon. We have oxygen. We have carbon dioxide, water. This carbon dioxide and water give it away. Anytime that those are your only two products, you know that is a combustion reaction. Okay? So a lot of the times people think of fire whenever they hear the word combustion. Okay? So let's look at our real world example. Doug and Betty go to the movies in Doug's cool car. The gasoline in Doug's car combusts, producing enough energy to power the car. Water from the combustion reaction drips out of the exhaust pipe. Okay? So everybody's happily ever after now after switching all of their dates around. So, big thing to remember is that oxygen, aero, carbon dioxide, water never change in a combustion reaction. All right, key points of our notes today. Endothermic absorbs energy while exothermic releases energy. There are 5 types of chemical reactions. Okay, and our last key point is combustion always makes water and carbon dioxide. Okay, so what that means for you guys is that you're going to have to look at chemical equations. So if I look here, you're going to have to look at these equations and know that they are single replacement. Okay, you'll have to look at these equations and know that they are decomposition. All right, so the main thing you got to do is identify these things. All right, what I have done in Canvas is I have included a Quizlet learning thing, which is a very good way to practice types of reactions if this video isn't enough for you. So let me show you Canvas. Okay, right here on Canvas, across from Tuesday, great practice for types of reactions. If you just click on this, it'll take you to that link, and it'll take you through the 5 types of reactions, and you'll get really good practice identifying those types of reactions. Okay, so after you watch this video, you can keep the PowerPoint pulled up if you need to. You're going to go do 6.3.1 assignment, what are the types of chemical reactions? And it's just a bunch of identifying and things like that. Don't forget that you can always email me if you need to. Okay? Y'all have a great Tuesday. I'll talk to you guys later.